This meeting is being recorded.
For problem 7 from chapter 21, we're asked to take a look at each of these three pairs of compounds and identify which compound is more acidic and then give a brief explanation as to why. So for our first set of compounds, we see on the left-hand side here, I've drawn 2,4-dimethyl 3,5 heptane dione. And then on the right-hand side here, we have the 4,4-dimethyl 3,5 heptane dione to compare. And if we were to deprotonate these and generate a stabilized conjugate base, we could see that in this first structure here, if we were to remove a proton, say from this site here, this would be where it would be deprotonated. And then we could form this resonance stabilized conjugate base over both of these oxygens here. So we would generate a more stabilized conjugate base, and then we would see that any protons that are removed from these sites here, these could only form a conjugate base that's stabilized over one oxygen. So that's why this first compound is more acidic, because it has a more stable conjugate base with that negative charge distributed over two oxygens instead of one. Let's take a look at compound B. We're going to see something similar here. We have on the left-hand side the 1,2-cyclopentane dione. Then we have on the right-hand side here, we have the 1,3 version of the cyclopentane dione. So if we were to deprotonate either site here, we could form the conjugate base and have resonance stabilization, again, only with one of these carbonyls. But if we were to deprotonate in between of the 1,3-cyclopentane diene, we could have resonance stabilization of the conjugate base over both of the oxygens. So therefore, this compound is more acidic for those reasons. Compounds C, we're going to compare here, it's aldehyde, and then over here we have our acetophenone. Notice that this is an aldehyde, and we do not have the acidic proton like we have with these this ketone over here. We have our alpha protons here, which will be acidic, and we could form a resonance stabilized conjugate base after deprotonation. So for those reasons there, acetophenone would be our more acidic compound.